Thank you for joining us on this webinar to go over the enhanced constraint flow manager that we have in our Libero tool set. So here's our agenda. We're going to talk about our traditional constraint methods and some challenges. We'll talk about our new enhanced constraint manager flow. I'll compare the classic constraint flow that used to be in Libero to our new enhanced constraint flow. I'll show you some different screenshots, how you constrain with the new constraint flow, and then we'll talk about which families are supported. So this slide is kind of busy, but it shows our design flow from creating our design and all the steps that we go through afterwards. So once we've created our design and we've synthesized or simulated it to make sure that it's functionally correct, we're going to move into the synthesis step, and then after that we're going to go into layout and timing verification. And when we get into these steps, there's a number of different constraints that we're going to apply. Constraints for synthesis, there may be timing constraints, they may be constraints to drive the mapping of the synthesis tool. Then we'll have timing constraints and physical constraints for layout. And then finally, we'll use timing constraints to verify the timing and make sure we've met our timing objectives. And once we've met all of those, then we can go off and move on to the next steps after running layout, so that we can go off and hand off the design for firmware development. We could program our device and so on. So it's in these steps right here, synthesis, place a route, and verify timing, that we have a number of different timing constraints that are applied. And that's why we tried to simplify things with the new enhanced constraint manager that's in Libero SoC. So some of the challenges that occurred with traditional timing constraint methodologies were applying and editing constraints for multiple stages in the design flow. We have constraints for the I/O attributes, pin assignments, I/O standards, attributes like pull-ups, pull-downs, Schmidt triggers, delays on the inputs. We have timing constraints for synthesis, timing constraints for layout, timing constraints for timing verification after layout. We may want to do some floor planning, and there may be some netlist attributes that we use. And we have netlist attributes that can be used both for synthesis and for layout. So we have different constraints that get applied at different stages of the design flow. We have timing constraints for synthesis. We have timing constraints for layout. Previously, those were managed by separate tools, even though they were essentially similar or very similar or even the same files. So we end up having time spent where we have to create constraints for our clock domains, maybe for some hard blocks in the design like microcontrollers or SerDes blocks. And in our open third-party tools, required to have those constraints applied interactively as well. We introduced RTL constraint editor in Libero SoC 11.6, but until we brought out the enhanced constraint flow, users had to enter all these constraints at initial stages of the design to avoid having to recompile, and sometimes you had to enter constraints in different tools at different times. So to address this, Microsemi introduced the enhanced constraint manager in Libero SoC 11.7. The Enhanced Constraint Manager tool is a centralized GUI that allows you to apply, edit, and manage design constraints for the entire design flow in one place. So we can manage I/O attributes, timing constraints for synthesis, for layout, for timing verification, floor planning constraints, and netlist attributes for synthesis and for layout. So we have a single set of constraints for all flow stages, for synthesis, for place and route, and for timing verification. And we've also introduced automatic generation of clock constraints for known blocks, such as oscillators and PLLs. So if you create a Libero SoC project using Libero SoC 11.7 or later, once you've gone through the new project wizard, a dialog box will open, and it will ask you if you want to use the classic constraint flow or if you want to use the new enhanced constraint flow. If you choose the enhanced constraint flow, that will allow you to use this new GUI that I've been talking about. What I'm showing here is the Libero SoC design flow window for the classic constraints flow on the left and the enhanced constraint flow on the right. The design flow window is where we go to launch all of our tools to create our design. Then we can verify the design. We can constrain the design, and then we can run layout and we can verify the design and so on. So it's the one window that allows us to go all the way through creating design and running the tools to run layout and so on. We also keep track of the design state in this window. Now in the classic constraint flow, we had editors that you could use to create constraints like I/O constraints or timing constraints or floor planning constraints prior to synthesis. And then we had GUI tools that you could use after synthesis to create essentially the same constraints. We've unified all of that in the enhanced constraints flow, where you'll just see a item that says manage constraints, and this will open the enhanced constraint flow manager, where you can create all of your constraints using either text tools or GUI-based tools. So let's take a look at some of these here. We'll start out with the Enhanced Constraint Manager, and you'll see that when I open the Enhanced Constraint Manager, I'll have 4 tabs that will be visible: I/O Attributes, Timing, Floor Planner, and Netlist Attributes. If I've gone through and run synthesis on my design, then I can open interactive tools to set my I/O attributes. So we have a tool that's called the I/O editor, and if I click on the I/O editor button, it will open a GUI tool that lists all of the ports and lets me set my different I/O standards, set my pin number. I can set other attributes, like if I have a pull up or a pull down, if I have a Schmidt trigger on my inputs, and so on. There's a couple of other tabs that are available as well in this GUI. We have a package pins tab that shows all of the package pins. So you can not only see the ports in the design, but you see all the pins. You see the VSS and the VDD pins and any other special pins. And you might use this to keep track of how many pins are next to each other in case of simultaneously switching output concerns or something like that. And we have a third tab that's the package viewer that actually shows the package, and you can see where the pins are on the package. In the package pin viewer, you'll see rectangles that represent pins. Some are red; those would be special pins or unbonded pins. Some might be green with a black center, meaning that those are pins that have not been assigned. Or you might see pins that have a filled-in center. That means that those are assigned pins. You'll also see different color backgrounds here. The IOs are organized in banks, so we have different color coding for the different IO banks. And when you move your mouse over the top of a bank, it gives you information about that IO bank. We also have a graphical tool that's called the IO Advisor. The IO Advisor can be launched from the IO Attributes tab in the Constraint Manager. And the IO Advisor will make suggestions for the IO attributes that you've selected, and it will tell you what the impact will be on the power. So after you've run synthesis, if you've done power analysis using our power analysis tools, and you've found out that you have exceeded your power budget and a lot of power is being consumed in the IOs, then the IO Advisor tool can make suggestions for you. Will make suggestions like changing the drive strength perhaps, or changing the slew rate. It will tell you what the impact will be on the timing, and it will also tell you what the impact will be on the power. And you can choose to accept the suggestion or ignore the suggestion, but it makes it easy for you to try to reduce the power that's consumed in the IOs without having to go back and do a lot of trial and error and see what the impact is on the timing. Now we can use those IO graphical-based tools after we run synthesis, but we also can bring in text tools. So if we move to the left here on the IO Attributes tab and say New, I can create a new IO constraint tab, that constraint file that's a text file, and I can even create a little template file if I say Create New IO Constraint from Root Module, which will open the text editor for me, and it will list all of my ports with some of the parameters, the name, and the direction, and then I can go in and I can put in my pin assignments. So I can use a text file, which I could save. I could import it at a later time. I could import that using a Tickle script if I wanted to. Or I can use the graphical tools after synthesis. Other things we can do is we can import a file. So if I already had a constraint file that I'd used previously, and I have a new project with the same die and package, and I want to use the same pin assignments, I could import that file. We can also link to files if we want to. Linking to a file allows you to use a file without making a copy of it and bringing it into your current project. We have another tab that's our timing tab that allows us to create our timing constraints. The timing constraint format that we use is the SDC format, the synopsis design constraints. And we can constrain at the RTL level. So we can implement our design, verify it's functionally correct, and then we can create timing constraints for synthesis, for layout, and for timing verification all at one time. This reduces the need to use the Synplify Pro scope editor to create your timing constraints. Makes it easy for you to have consistent timing constraints between the tools. You enter the constraints one time, and you can decide if you want the constraints for synthesis, for layout, for timing verification. You can have one file that supports all three of those, or you could have separate files, one for synthesis, one for layout, one for timing verification if you wanted to. Any constraints that you enter either through the text editor or through the graphical GUI-based tools are saved as SDC files, and you can open them in an editor. You could modify them. You could import those files into a project later on. And we can dynamically create timing constraints for known blocks like PLLs, oscillators, as well as some constraints for the SerDes blocks and for the microcontroller subsystem in SmartFusion 2. So here's our constraint editor. I choose the timing tab. I can create constraints, and I can edit constraints from this window. If I have constraints that are already existing, I might have imported those, or maybe I created them previously. I could edit the constraints, and I can choose to edit the synthesis constraints, the place and route constraints, or the timing verification constraints. And this is a look at the graphical tool. This is our SmartTime constraint editor that allows me to go in and graphically enter my constraints. I have requirements, clocks, generated clocks, input delay and output delay, as well as exceptions. And then we have some advanced constraints you can enter too, things like clock source latency. When I create timing constraint files in the constraint manager, I can specify where I want those constraint files to be used. Do I want to use it for synthesis? Do I want to use it for place and route? Do I want to use it for timing verification? You could have one file that you use for all three steps, or you could have separate files for each step if you wanted to. So if you wanted to over constrain for synthesis and for place and route, for example, you could have certain timing constraints just for those steps in the design flow, and then have a third constraint file that has your exact timing requirements when you do your timing verification, so you can make sure that you're meeting all your timing objectives. Here's an example of an SDC file that might have been generated through the tools. We have create clock, create generated clock. We may even have some exceptions in here, so you can see some false path exceptions. So I could create those files either graphically or with a text editor, or in some cases we can actually derive these constraints based on known blocks. But once I have my constraint files, I can specify where I want to use them in the flow, and then I can also open the tools, open the constraint files in an editor, and I could edit them if I needed to. We have constraint checking built in. It's particularly useful if you create a new constraint file using the editor. You can go in and you can check your synthesis, your place and route, and your timing verification constraints to make sure that you don't have any syntax errors in the constraints before you try to use them with the different tools. And for timing constraints, we have another option. We have what's called generate constraint coverage. So you can generate a constraint coverage report, and the constraint coverage report will look at the timing constraints that you've entered and will make enhancement suggestions in case you've missed any. So if I only put in my clock constraints and I forget to put in input delay constraints or output delay constraints, it will make suggestions that I didn't add those constraints, and I might want to add those so I make sure that I fully constrain the design. So creating the constraint coverage report is a good idea to make sure that you've fully constrained the design before you run synthesis and layout and timing verification. The next tab over is the floor planner tab. And the floor planner tab allows you to do floor planning, which means that you can tell the placer where you want to put the logic on the die. So again, we can create a floor planning file using a text editor, or we could import or link to files. We can also open a graphical tool called Chip Planner, and Chip Planner will allow me to see an outline of the die, and I can graphically tell the placer where I want blocks of logic to be placed. That will restrict where the placer can put the logic. And then after I've run layout, you can open Chip Planner again. You can use it as a viewer, and you can see exactly where the logic was placed. And you can cross-probe between the Chip Planner tool and the static timing analysis tool. So if you're not meeting your timing objectives, you can see not only where the delays are, but where the logic was placed, and perhaps develop some strategies to try to improve the performance of the design. The last tab is the Netlist Attributes tab. And the Netlist Attributes tab allows me to put in two different types of Netlist attributes, one for synthesis, which is called an FDC synthesis attribute constraint, and another one for layout, which is called an NDC. Both of these, FDC and NDC, are text editor files only. So you would open the text editor and put in these synthesis constraints, the FDC constraints, which control the synthesis tool mapper, or this NDC for running layout. So the Synplify Netlist constraint files, these FPGA design constraints, or FDCs, these are non-timing design constraints that are used to optimize the netlist in Synplify Pro. And some examples of the attributes that you can put in are things like syn no clock buff, which prevents Synplify Pro from assigning a net to a global net. There's syn RAM style, which allows you to specify when you're inferring RAMs, if you want to map to flip-flops or if you want to map to RAM blocks. And then there's syn mult style, which allows you to control mapping to the DSP blocks that are in SmartFusion 2, Igloo 2, and the new PolarFire families. The Synplify Pro help has a link to reference documents, which will allow you to access the attribute reference guide, which is a really good place to look if you want to get more information on using these attributes, or there's multiple other attributes that you can use as well. So here's a look at Netlist attributes. You create these with the text editor, so you can say new, and you can open the text editor and you could add these attributes, or you could import a file if you've already had one, or you could link to a file. And then there's a checker for all of these constraints, so you can make sure that it's syntactically correct. The other attribute file that can be used, which is actually used with the layout tools, is an NDC. NDC constraints are non-timing constraints that are used for layout. And there's really only two commands that can be used in an NDC file today. One puts a preserve property on instances before we go to the layout step to prevent them from being removed. And the other one is to specify whether or not we're going to use the I/O flip-flops. So in Synplify or in SmartFusion 2 and Igloo 2, we have I/O pads that have flip-flops built in. The synthesis tool doesn't use those I/O flip-flops. The layout tool will automatically try to use them if it can improve your timing based on your timing constraints that you entered. But if you want to guarantee that they're always used, you can use this set_IO_FF command and tell the tool that you want to replace a flip-flop in the FPGA array with the flip-flop in the I/O pad. So here's an example of an NDC file where you see these commands set_IOF for different ports. Basically, in some cases, we said no for the register, and in some cases, we said yes. So I kind of walked you through quickly on the enhanced constraint flow, and I just wanted to show you which families are supported with this flow. So the third generation flash families, ProASIC 3, Igloo, SmartFusion, and Fusion, are supported with the classic constraint flow, but they are not supported with this new enhanced constraint flow. The enhanced constraint flow supports SmartFusion 2 and Igloo 2, the RTG4, the new flash-based space devices, and our newest family, PolarFire. And in fact, PolarFire is only supported with the enhanced constraint flow. It's not supported with the classic constraint flow. As far as changes to SmartTime, which is our static timing analysis tool, we will do our timing analysis based on constraint files that will show up on the timing tab in the constraint manager if you specified them for timing verification. So here's an example where I mentioned I could have multiple SDC files, and then I would specify if I want to use them for synthesis, place and route, or timing verification. So here we have some files that are used for timing verification, but not all of them. We can also cross-probe between some of the different tools. So we can cross-probe between the SmartTime timing analyst tool and the chip planner tool. So I can look at paths, see the logic in the path and the delays, and then I can cross-probe that with the chip planner tool to see exactly where that logic was placed on the die. We can also cross-probe between the static timing analysis tool and the constraint editor to allow me to enter any exceptions that I might have forgot to enter when I first constrained my design. So if I look at a path that has a violation and I study it and I realize that I should have put a false path exception there, or maybe that's a multi-cycle path, I can add an exception while I'm doing my timing analysis and regenerate the design, or regenerate the delays, and then see if I still have any violations. So I don't have to go back and reconstrain and then run synthesis and run layout again. I can enter my exceptions even while I'm doing my timing analysis. If I realize I forgot to put an exception in, then I can regenerate the delays and I can see where I stand with meeting my timing objectives. Dynamic constraint editor from SmartTime is not supported with the enhanced flow. So I can't go back and open the timing analysis tool and change my clock constraints and things. I would have to go back and go back to the constraint manager and change my constraints and then run back through the flow. But I can enter exceptions while I'm doing my timing analysis. Project migration. If you have Libero SoC projects that were created using version 11.6 or earlier, then they're not migrated automatically to this enhanced constraint flow. When you open them in Libero SoC 11.7 or Libero SoC 11.8, they will still be using the classic constraint flow. If you want to go to the enhanced constraint flow, you would need to create a new design from scratch and select the enhanced constraint flow when you go through the project wizard. And if you create a new project from scratch, but you forget to choose the enhanced constraint manager, then you'd have to start over again. So there is no switching from the classical constraint to the enhanced constraint and so on. You have to make that choice when you create the project, and then you can move on from there. Okay. We have some time, so why don't I bring up a Libero project and just go through the tools one more time, since you might be able to see things a little bit more clearly than what you could see in the slides, and then afterwards we'll see if there's any questions. So hopefully you can see my screen. I brought up a Libero project. This is a Smart Fusion 2 project. It has the microcontroller subsystem configured, and it has some logic in the FPGA fabric. And I'm going to open the constraint manager here. And here's the tabs I talked about. So here are the IO attributes tabs. This is where I could go in and I could create constraint files for my IOs. And I could create a new file with the text editor. And I could say I want to create a new module from the root. Let me just call this, I'll call it top IO, for example. And it will open the editor. You will have the set IO, that's the PDC command for making the IO assignment, and it will list all of my ports and the direction. So this is just a template. It's just a starting point for me where I could go in and I could make my assignments to the pins that I have in my design. I could save that. We'll see it on the constraint manager here. So it'll show up. Now, when I put something on the constraint manager, if I don't check it, it's not actually going to be used. Also, if you right check on a constraint, you see you have some various different options here, and one option is to set as target. What that means, if you set a file as the target, you'll see it say that it's the target, and if you set it as the target, any changes you make in other tools, for instance, if I open a graphical tool or something, then it would make the changes in the file that's set as the target. If I don't set a file as the target, then it would create a separate file. I could import a file, or I could link to a file. I could edit a file if it was already there, and I could check the file to make sure it's correct. Now, I could edit with the IO editor, which will open up the graphical tool that I showed you, and this will show me all of my ports. I can choose my IO standard, and I could come in here and I could make my pin assignments. So I could do it this way, and I could save, and I believe in this case it's going to give me a see, it gave me a second file that it set as target because I didn't set top IO as the target. So if I would have set this one as the target, then when I edited, it would have put those pin assignments in that file. So you see in here, there's just one pin assignment because I only made one of them. If I were to go back and edit other pin assignments, it would put them in there. So I could have multiple pin assignments files if I wanted to, and I could use them both, or I could just stick with one. So that's the IO attribute tab. If we move to timing, I could create a new constraint file using the text editor. I could import or link to a file. I could edit using the constraint editor. Let's just look at this one. We'll edit the synthesis constraints. This will open the SmartTime constraint editor, and here I could go in and I could add other constraints, input delays, output delays, for example. We have some advanced constraints like clock source latency that you could use to specify insertion delay. You could use that if you wanted to try to specify jitter, for example, on some clocks. I could also derive constraints. Now this particular design has some known blocks. I'm using an internal oscillator as a reference clock for a PLL, and because of that, the tool knows what the clock frequency is for the oscillator, and it knows what the output clocks are because it knows the configuration of the PLLs. So it created a create clock. This is my clock constraint for my oscillator. It's a 50 megahertz oscillator, and then it create generated clock is the constraint for the outputs of the PLL. And it also created some exceptions. There's some paths in these blocks that we want to ignore for timing analysis. So it created these for me automatically. And I can come back and I can say, if I wanted to use those just for synthesis, if I wanted to use them for place and route or for timing verification. So if I wanted to over constrain, I could have multiple constraint files and maybe just use one constraint file for synthesis and place and route, maybe a third one or second one for timing verification. You can check your constraints here, check the synthesis, place and route, and timing verification constraints. And we can also do our constraint coverage. So let's just take a look at that quickly. It will come through, look at my constraints, and then make suggestions if there's things that I haven't constrained. So we'll open this report view, and you see here it's making enhancements. Max input delay is missing on some ports, min input delay, and so on. So this lets me look at my constraints and make sure that I fully constrained everything before I go through and run the different tools. Moving on to the floor planner. This is where I could do some floor planning if I wanted to. And you could create a text file, although I think personally creating a floor planning text file without intimate knowledge of the architecture is a little bit difficult because you have to know where all the different blocks are. But we could open with we could open that with the chip planner tool. Unfortunately, when I created my timing constraints, I invalidated synthesize, so I have to resynthesize to do that. But this would let me open the graphical tool that would allow me to graphically specify on the die where I want logic to be placed. And then Netlist Attributes. This is the text files, either an FDC or an NDC file. That I would create with the text editor to control synthesis mapping with an FDC file, or to control the usage of the I/O flip-flops with an NDC file. So to summarize, the new Enhanced Constraint Manager tool puts all your constraints in one central location, and it allows you to apply, edit, and manage all of those constraints for optimizing your design from synthesis through layout and timing verification. It lets you have a single SDC file for both synopsis and the Microsemi layout and timing verification with the SmartTime tools. Supports derived constraints for known blocks like PLLs, the microcontroller subsystem, using constraints for the internal fixed oscillators in SmartFusion 2, Igloo 2, and PolarFire, as well as constraints for the SerDes blocks. We can cross-probe when we're doing timing analysis between the SmartTime tool and the chip planner tool. And we can also cross-probe between the SmartTime timing analysis tool and the constraint editor so that we can add any exceptions we might have forgot to add when we're doing our timing analysis without having to go back and then run synthesis and run layout again. So it saves time, allows you to apply the constraints all in one place. I personally think it's much more intuitive to have all the constraints in one place prior to what we had in the classic constraint flow, where we had constraints that were text editor based before synthesis and then constraints that were GUI based after synthesis. Now everything's all in one place. So I think it's a lot easier, a lot more intuitive, and I think it'll give you more control over your constraints as you're going through designs. Thank you for taking time, allowing us to have about an hour of your time to go over the new enhanced constraint flow that we have in Libero. We appreciate you spending time with us today.